Let us consider one unsymmetrical arch here. A unsymmetrical parabolic arch of span 20 meter has two hinges at the fringes, one at the highest point of arch, which is 9 meter and 4 meter above the left and right supports respectively. The arch is loaded with UDL 30 kN per meter, covering a horizontal distance from left support to the highest point of arch. Find the reactions at the supports and normal thus radial shear at 4 meter from right support. So this is the ACB's arch. His span is 20 meter. So highest point of the arch is 9 meter from left support, that is here, 4 meter from the right support. It carries a UDL of 30 kN covering horizontal distance from left support to the highest point. Highest point is here, left support is here. It is a horizontal distance. It carries a 30 kN per meter. So now let the horizontal distance between the support A and the highest point be L1, and similarly highest point to support be L2. The span is given 20 meter, that is nothing but the horizontal distance of EB. Now first we need to calculate L1 and L2 in order to calculate the reactions. So with the equation of parabola with A as origin is, you know that 4h by L square x into L minus x. But here this L is not 20 meter, it is L is 2L1, because we are using this equation when the supports are at same level, that is A, C, B dash. If you consider a arch with supports A and B dash at same level, then A, B dash will be your L. A, B dash is nothing but, if this is L1, this is also L1, so it will be A, B dash is 2L1, right? So H is, this is the highest point of the arch from the left support, that is 9 meter. So now using the boundary conditions with this geometry, at x equals to 20 meter, means from A x equals to 20 meter it comes support B. At x equals to L1 means C, at x equals to 20 meter means B. At B, what is the height of that point with respect to A? That is this. This is nothing but, this is 9, this is 4. So 9 minus 4 will be 5 meter. So at x equals to 20 meter, y equals to 5 meter. Substituting these values in this equation, that is y is 5, 4, h is 9, L1 is 2L1, sorry, L is 2L1 square, x is 20, again L is 2L1 minus 20. If you simplify, this will become a quadratic equation. After solving, you will get here L equals to 12 meter. Now, you can calculate L2 by using, just you know that here L1 plus L2 equals to 20 meter. Therefore, L2 equals to, that is 20 minus L1, that is 20 minus 12, that will be 8 meter. So once if you get the values of L1 and L2, now you have to calculate the support reactions, that is VA, VB and H. See here directly we will not get VB and H, because if you write sigma MA equals 0, VB and HB will be unknowns. If you write sigma MB equals 0, VA and H will be unknowns. So you need two equations to get both the unknowns. Say first sigma Fx, because here it carries only purely vertical load, hence it is HA minus HB. HA minus HB equals to 0, hence HA equals to HB, that is H. Now, if you take moment about A, that is sigma MA equals to 0, you know that it is, see here, this is causing VB, that is minus VB into this much, that is 20. This is minus VB into 20. Then H, if you turn that tip of the H towards this A, so this is like this. This is also causing anti-clockwise. So HB into, what is the distance between this support and this is 5 meter, so minus HB into 5. But this UDL is carrying, causes clockwise moment, that is plus 30 into this much is 12 meter, L1 is 12 meter, it acts at the center. From here to here you are taking moment about A, so it will be 30 into 12 by 2, this equals to 0. Here you will have VB and HB as the unknowns. Now let us write one more equation, that is bending moment at C equals 0, consider from right side, because in this equation also VB and HB should be unknowns, so that you can solve two unknowns and two equations. If you write bending moment at C, considering left side, see for bending moment always left side anti-clockwise positive, clockwise negative, and for writing sigma MA, that is static equilibrium, you can take minus anti-clockwise plus clockwise, that is clockwise as plus, or reverse also can be taken. For bending moment, right side anti-clockwise is positive, hence this is VB into L2. What is L2 now? This is 8 meter. VB into, here you are writing bending moment C. Then this is anti-clockwise. But this, if you turn this H towards C now, this causes clockwise. See now, if this is anti-clockwise positive means clockwise will be negative. So HB into, what is this distance? This will be 4. So you will have two equations, two unknowns. Solve for those. That is, after solving you will get VB equals to 72 kilonewtons and HB equals to 144 kilonewton. HB equals to HA, that is H equals to, so it is 144 kilonewton. So now after getting this H, now you can get VA also, suppose if you want. Therefore VA is what? It is VA plus, if you write sigma Fy, VA plus VB equals to total downward load, that is 30 into 12. Therefore if you calculate here VA, what is VA here? 30 into 12. So you will get the value of VA. VA you are going to get here 288 kilonewton, right? This is how to get the reactions. Once if you get the reactions, now you need to calculate what is asked actually, normal thrust and radial shear at 4 meter from right support. Okay, so now I have considered one section here, 4 meter from the right support. This is x equals to 4. This is the section. The perpendicular to that will be normal thrust, parallel to that or tangential to that will be radial shear. And if you draw at this section one horizontal and vertical line, the force acting along the vertical line is called as a vertical shear. The force acting along the horizontal line is called as a horizontal thrust. These two should be calculated by using for keeping this part in equilibrium. Okay. Now we need to have to calculate bending moment. Now let us calculate bending moment also, though he has not asked. But y is equals to, you know that 4h into L square x into, but what is h here? L here you are considering B as the origin. With B as origin, now L is equals to 2L2. If you take A as origin, L is equals to 2L1. If you take as B as origin, L2 is B to C horizontal distance. When you take the symmetrical arch with respect to here, with respect to B, L will be 2L2. Okay. Now if you put x equals to 4 meter here, 4 into h is the, when you take B as origin, h is again 4 meter here. L square is 2L2, that is 16 square into 4. L is again 16, x is 4. You will get 3 meter. And tan theta equals to, you know that dy by dx. If you take the derivative of this, it is 4h by L square, L minus 2x. Substituting again L as 2L2, x as 4 meter, you will get 0.5, and theta equals to tan inverse of 0.5, you will get theta equals to say 26.5 degrees. Then you need to calculate here vertical thrust and vertical shear and horizontal thrust. Vertical shear is 72, you have to write sigma Fy, 72 minus V equals to 0. That is 72 minus V equals 0, V equals to 72. Then horizontal thrust, this is plus h minus 144, that is plus h minus 144 equals to 0, hence h is equals to 144. So once if you calculate this y, then theta, then vertical shear, horizontal thrust, you can calculate now. Normal thrust, you know that, what is the formula? V sin theta plus h cos theta. Substituting V, h and theta, normal thrust you will get 761 meter. Then radial shear, V cos theta minus h sin theta. Again substituting h, theta, V values, you will get this as 0. Now suppose if you want to calculate bending moment here, again that is what nothing but here. What is this? See now, it is 72 into 4, right? 72 into 4, anti-clockwise is positive. Then this is clockwise, negative. 144 into YD. What is that? 144 into 3. 72 into 4 here. 72 into 4 minus 144 into this YD. YD is nothing but we have calculated a 3 meter. So here 72 into 4 minus 144 into 3, you will get here minus 144 kilonewton meter.